Hey everyone, let's jump right into this explainer and unpack one of the most unconventional, absolute mind-bending scientific pitches we have ever come across, the Ortiz Quantum core. Our goal today is to just neutrally map out exactly what these folks are proposing, because we're looking at a pitch that claims it's going to completely rewrite the rules of computing from the ground up. We're talking about moving away from those massive, resource-heavy setups to something incredibly small and, honestly, astonishingly powerful. Now, whether this turns out to be the ultimate scientific breakthrough of our lifetime or just an incredibly elaborate theoretical model, the concepts we're about to explore are guaranteed to stretch your imagination. So let's get right into it.
There is this really fantastic, provocative quote directly from the source material that perfectly sets the stage. They use this analogy, saying it's like claiming the future of transportation is a horse that needs to be kept in a castle, to argue that our current $1 million super-cooled quantum setups are frankly completely absurd. The pitch points out that today's leading quantum computers, the ones built by the massive tech giants, rely on chips that are a 10,000th of a millimeter thick. But to make them work, they have to bury them inside $1 million machines that are literally colder than deep space. According to the creators behind the Ortiz core, the underlying physics of quantum mechanics is absolutely real. But the way we're currently trying to use it, it's fundamentally flawed and hopelessly clunky.
Think about the sheer scale of the paradigm shift they're proposing here. It's a true David and Goliath situation. On one side, you have the current reality, massive metal cryostats running at a staggering minus 273 degrees Celsius, using intense liquid helium cooling, and costing anywhere from $50 to $100 million a pop. And then, on the other side, you have the Ortiz pitch. They're proposing a chip roughly the size of a standard SD card, just 15 by 11 by 1 millimeter. And get this, it allegedly runs at a maximum temperature of just 42 degrees Celsius. That's essentially room temperature. And the cost? Exactly 85 cents to manufacture. It's almost hard to wrap your head around.
Now, let's talk numbers, and I mean massive, mind-boggling numbers. Take a second to just absorb the mathematical scale of their primary claim. The source asserts their chip can perform 1 octillion operations per second. That is a 1 followed by 51 zeros. It's a number so incomprehensibly huge that it kind of breaks standard logic. They're arguing that this isn't just a hardware upgrade. It represents an entirely different category of mathematical capability altogether. To put a number like that into some kind of human perspective, let's compare it to the absolute heavyweight champion of the world right now, the Frontier supercomputer. It's the fastest supercomputer on Earth, and it operates at a blistering 1 quadrillion operations per second. That's 10 to the 18th power. But the Ortiz core is claiming an output of 10 to the power of 51. That makes it 10 to the 33 times more powerful. The source actually points out that if the massive Frontier supercomputer did exactly 1 operation per second, the Ortiz chip could do 100 trillion times the operations of the entire history of the universe in that exact same single second. It's wild.
Okay, so you're probably thinking, where is the proof? Claims like this obviously demand hard data. Well, rather than just relying on theoretical guesswork, the source leans heavily, and I mean heavily, into simulation data. They claim to have run 1.58 million highly detailed simulations testing every single theoretical component of this chip. We're talking quantum field convergence, diamond crystal integrity, thermal stability, you name it. And they are reporting a virtually perfect 100% pass rate across almost every single category, with fabrication repeatability scoring 99.87%. They present this massive wall of data as hard proof that their model is completely viable.
So how are they supposedly doing this? Let's move to Section 2, the secret sauce, featuring 3 bizarre innovations. The creators essentially argue that standard wires and clock speeds are complete dead ends. First up is something they call flower of life routing. Now, I know that sounds a bit mystical, but the source clarifies it's actually a strict mathematical hexagonal grid. The crucial point here is how the data travels. In your normal everyday computer, information travels through tiny wires from point A to point B. It takes time to cross that physical space, a concept called distance latency. It's literally like flying from New York to London. But with this hexagonal pattern, every single atom on the chip is reportedly connected via quantum entanglement with 0 distance. It acts like every atom is sitting right there in the exact same room, providing instant shortest path routing. And they claim this creates a massive 10 to the 34th power multiplier in operational speed. Then there is the second innovation, which is frankly just wild. They call it whale logic compression. The creators apparently studied how sperm whales communicate using echolocation clicks deep in the ocean, and they identified it as nature's absolute ultimate compression algorithm. By mapping this highly efficient natural click pattern, they claim they can compress quantum states on the chip to gain a multiplier of 1 million. And this compression is supposedly the magic key to packing over 10,000 qubits onto a single SD card-sized chip, letting them completely bypass the need for those extreme freezing temperatures. The final piece of their puzzle is zero-point coupling. We all know that traditional electronics constantly lose power as heat. I mean, that's exactly why your laptop has a noisy cooling fan. But the Ortiz pitch claims to solve this using specific carbon structures called shungite fullerene cages. These cages allegedly enable 100% power efficiency with zero energy lost as heat. This completely explains their staggering claim that the chip draws less than 1 watt of power, can run straight off a standard phone charger, and peaks at just 42 degrees Celsius. Theoretically, it just passively cools itself. What's just as fascinating as the math is the physical materials stack. They are completely abandoning traditional silicon and glass. Instead, the foundation starts with lab-grown synthetic diamond, chosen for its extreme thermal conductivity. They layer that with a 2D material called molybdenum disulfide and then top it off with graphene to handle thermal connections and provide EMP shielding. They even use pure food-grade magnesium and zinc to enhance the electrical properties. That's right, food-grade materials to avoid introducing any random contaminants. So how does the math actually stack up to reach that octillion number? This sequence breaks down their exact justification, and it's super important to grasp because they are entirely throwing out the traditional concept of clock speed. You start with 10 to the 25th power atoms perfectly packed into that synthetic diamond. Then you multiply that by the 10 to the 34 resonance from the flower of life zero-distance routing. Finally, you apply the million times compression factor from the whale logic. If you actually multiply all of that out, you get 10 to the 65. But they boldly claim that scaling it way back to a conservative 10 to the 51 operations per second still leaves all current tech completely in the dust.
The pitch makes a really great point about the nature of progress here. They want to drive home the difference between a standard technological upgrade and a true paradigm shift. Upgrading from a horse running 30 miles per hour to a jet engine flying at 600 miles per hour, that is only a 20 times improvement, and that completely changed the world. But moving from the world's best supercomputer up by a factor of 33 zeros, they argue this isn't just a faster processor, it represents a completely unrecognized category of physics.
Let's compare these two worlds directly. Look at the intense centralization required today. That Frontier supercomputer uses 21 megawatts of power, costs $600 million, and is strictly for government use. Google's Sycamore costs $100 million and is locked deep in a lab. Even those high-end enterprise AI chips like the NVIDIA H200 are going to run you $30,000 a piece. Contrast all of that with the claimed Ortiz core metrics, less than 1 single watt of power, 85 cents to make, and you can access it literally sitting at your kitchen table. It is quite simply the ultimate decentralization of computing power.
So what's the so what here? What should we take away from this? Well, if these claims actually materialize, the real-world implications are staggering. In medicine, instead of massive supercomputers taking years to figure out how a drug molecule folds, this chip could supposedly simulate it perfectly in mere seconds. For the climate, it could instantly model complex chemical reactions to discover brand new carbon capture materials. The pitch even claims it would completely eliminate cell carriers. Think about that. The chip's power would turn every single phone into its own independent radio tower, creating a direct network. And fundamentally, an 85-cent chip with this much power completely shatters the modern cloud rental economic model we all live in today.
You might be wondering, okay, if it's so great, what is the holdup? According to the pitch, the theoretical blueprints and all of those millions of simulations are 100% done. The entire focus for the next 12 to 24 months is purely on physical manufacturing. And they aren't trying to build some massive billion-dollar factory. No, they are building a custom microwave-sized 405 nanometer purple laser printer that costs under $1 million. Once that desktop machine is built, it will literally print the diamond crystal structure and etch the chips in just 5 minutes per unit. Their timeline boldly predicts mass scaling within just 2 years, which in hardware manufacturing is an absolute blink of an eye.
We're going to wrap up this explainer by leaving you with a pretty massive question, straight from the implications of their pitch. We've explored the wild claims, the perfect simulated data, and the truly bizarre nature-inspired math. The source firmly asserts that our current monolithic computing era is rapidly drawing to a close. So if they're actually right, and a 1 octillion speed, fully decentralized computer really is coming to the palm of your hand, what will you build on your kitchen table? Thank you for exploring this fascinating pitch with me today.